Hey, I'm glad you're here. Whatever today brought you, the worries, the noise, the unfinished thoughts, you don't need any of that right now. Those things can wait. They'll be exactly where you left them tomorrow morning, I promise. Tonight, you don't have to figure anything out. You don't have to be productive or useful or ready for anything. You just have to be here. So if you want, let your shoulders drop a little. Let your breathing slow down. There's nowhere to be right now. Nowhere at all. And when you're ready, I'll tell you something wonderful about the Milky Way. Our galaxy has been quietly turning above every civilization that ever existed. Every bonfire, every sleeping child, every ship lost at sea. They all had the same river of stars overhead. Something about that feels deeply calming, like you're part of a thread that has no beginning and no end. So let's go there together. No rush. We have all night. The Milky Way is not just the name of our galaxy. It's what ancient people called the pale, dusty band of light that stretched across the night sky. A river, a road, a seam in the darkness. In Latin, they called it Via Lactea, the Milky Road. In ancient Greek mythology, it was the spilled breast milk of the goddess Hera, arcing across the heavens in a single, endless stream. Different cultures saw different things in that same soft glow. The Armenians called it the straw thief's path. The Finns saw it as the bird's way, a route that migrating birds followed south. The Cherokee of North America told stories of a dog who stole cornmeal and was chased away, scattering meal across the sky. Every culture looked up and saw something, a story, a path, a reason to feel less alone in the dark. And what they were actually seeing, without knowing it, was the combined light of hundreds of billions of stars, so distant and so many that they blurred into a single soft band. They were seeing the edge of their own home from the inside. We still live in that same galaxy. We're still inside it right now. The Milky Way is a barred spiral galaxy, a structure so large that if you tried to drive across it at highway speed, it would take about 450 billion years. And yet, from where we stand, it's just a quiet shimmer above the trees. Let that thought settle. You are inside something almost incomprehensibly large, and yet you are here, warm, safe, still. Close your eyes for a moment if you like. Let your body sink a little deeper into where you're resting. We'll keep going, gently. The Milky Way is approximately 100,000 light years across. A light year is the distance light travels in a single year, and light moves at about 299,792 kilometers per second. In 1 year, it covers roughly 9.46 trillion kilometers. So when astronomers say the galaxy is 100,000 light years wide, they mean a distance so vast that numbers begin to lose their meaning. They become something you feel rather than understand. Here is one way to feel it. If you shrank the Milky Way down to the size of the continental United States, from coast to coast, then our entire solar system, including the Sun, all 8 planets, and the Kuiper Belt, would be smaller than a single grain of sand. Let that breathe for a moment. A grain of sand in a continent-sized galaxy. And yet, from our grain of sand, we have figured out the shape of the whole thing. That is what science is sometimes, learning to see what you cannot step outside of. The galaxy isn't just wide, it has depth too. The disk of the Milky Way is roughly 1,000 light years thick in most places, and yet the central bulge, the bright heart at the center, swells to about 10,000 light years. Like a lens, like an eye, slowly blinking. Our Sun sits about 26,000 light years from the galactic center. That puts us roughly halfway out. In the suburbs, astronomers sometimes say, not in the crowded, energetic core, not in the lonely outer edges, somewhere comfortable, somewhere relatively quiet. There's something reassuring about that, isn't there? We ended up in a gentle neighborhood. The Milky Way is also not flat. It wobbles. The outer edges are slightly warped, bent up and down in a shape that looks a little like the brim of a hat caught in a breeze. Astronomers discovered this warp only in recent decades by carefully mapping the positions of thousands of stars in the outer galaxy. The warp is probably caused by the gravitational pull of nearby satellite galaxies, small galaxies in orbit around ours, tugging gently at the edges across millions of years. Everything, even at this scale, is in conversation with everything else. You don't have to hold all of this. Just let it drift past you, like clouds. Let your breathing slow. The galaxy will keep turning whether or not you follow along. We have time. The Milky Way is a barred spiral galaxy. That means it has a central bar, a dense, elongated region of stars crossing through the galactic nucleus, with spiral arms curling out from each end like the arms of a pinwheel. We have 4 main spiral arms. They have names: Perseus, Norma, Scutum Centaurus, and Carina Sagittarius. Our Sun sits in a smaller structure called the Orion Arm, sometimes called the Orion Spur, a partial arm nestled between Perseus and Carina Sagittarius. If you've ever looked at a photo of a spiral galaxy, those luminous sweeping shapes against the black of space, you've seen what our galaxy looks like from the outside. We just can't take that photo ourselves. We're inside the painting. Everything we know about the Milky Way's shape, we've pieced together the way you might reconstruct a house by exploring every room in the dark, mapping stars, measuring distances, counting hydrogen clouds, listening to radio waves that no human ear can hear. The spiral arms are not solid objects, by the way. They are more like traffic jams, regions where stars and gas and dust pile up as they orbit the center, creating a denser, brighter wave that rotates through the galaxy over hundreds of millions of years. Stars drift in and out of the arms. Our Sun has passed through spiral arms many times in its 4.6 billion year life. At the very center of the galaxy, hidden behind thick clouds of dust and gas, sits something extraordinary. A supermassive black hole called Sagittarius A star. Its mass is approximately 4 million times that of our Sun. 4 million suns worth of gravity compressed into a single point. Sagittarius. A star is about 26,000 light-years away from us. It is not consuming the galaxy. It sits quietly, mostly dormant now, exerting its gravity on the stars nearest to it. Some of those stars orbit it like bees around a hive, completing full orbits in just a few years, moving at thousands of kilometers per second. We have watched those stars orbit in real time through decades of patient observation. We have seen them bend around something invisible, and the invisible thing is real. Let that sit with you quietly for a moment. The center of everything we live in is a darkness so dense it bends light itself. And yet, here we are, 26,000 light-years away, warm and safe and drifting off to sleep. You are perfectly far from the center. The Milky Way contains somewhere between 100 and 400 billion stars. We say somewhere between, not because astronomers are being vague, but because counting them directly is impossible. Instead, scientists estimate by measuring the total mass of the galaxy and dividing by the average mass of a star. Different methods give different numbers. The honest answer is between 100 billion and 400 billion, a range of 300 billion stars, give or take. And each of those stars, each one, is its own sun. Some are smaller than ours, cooler and redder, burning so slowly they'll outlast the current age of the universe by trillions of years. Others are hundreds of times larger than our sun, so luminous that if you replaced our sun with them, the Earth would be engulfed. Most stars in the Milky Way are red dwarfs, quiet, long-lived, dimly glowing. If you could see them all at once, the galaxy would look far redder than the blue-white image we often imagine. Stars are not scattered evenly. In some regions, open clusters, globular clusters, they crowd together in spheres of thousands or tens of thousands, close enough that their night skies blaze with light in every direction. If you lived on a planet inside a globular cluster, there might be no real darkness at all. We live in a quieter region. Our nearest stellar neighbor is Proxima Centauri, 4.24 light-years away. That's about 40 trillion kilometers. So close, on the scale of the galaxy. So impossibly far on any scale we can walk. There are stars in the Milky Way older than the Earth by billions of years. Stars that formed when the universe was young and thin and had barely cooled from its beginning. Some of these ancient stars are so old that when they were born, there were almost no heavy elements yet. No carbon, no oxygen, no iron. The universe hadn't made them yet. Those ancient stars watched everything that came after. They watched the Milky Way assemble. They watched younger stars ignite, burn out, explode, and scatter new elements into the clouds that would form still younger stars, including, eventually, our sun. Our sun is a third-generation star. The carbon in your body, the iron in your blood, the calcium in your bones, all of it was forged inside stars that lived and died before our sun was born. You are made of ancient light that forgot it was light. Let your breathing slow now. Let your hands rest. Those ancient elements are still, for tonight, yours. Our sun orbits the center of the Milky Way. This is not a metaphor or a simplification. The sun, carrying with it the Earth and every other planet, is in constant, graceful motion around the galactic center. It moves at roughly 220 kilometers per second. That's 220 kilometers every second. And yet the galaxy is so large that one full orbit, one galactic year, takes approximately 225 to 250 million years. Astronomers sometimes call this unit a cosmic year. Our sun has completed about 20 of them since it was born. The last time the sun was in this same position relative to the galactic center, the dominant life on Earth was the earliest dinosaurs. 2 cosmic years ago, there were no land animals at all, only life in the sea. We carry all of that history with us as we move. The sun doesn't orbit the galactic center in a perfect circle. Like most stars, its path is slightly elliptical, and it also bobs up and down through the plane of the galaxy, like a horse on a carousel. It oscillates above and below the galactic disk every 30 to 35 million years. Some researchers have wondered if these oscillations might correlate with mass extinction events, whether passing through the denser plane of the galaxy brings more comets or cosmic rays into the inner solar system. The evidence is intriguing, but not conclusive. The universe is subtle about such things. Our sun is currently moving away from the galactic center very slightly, drifting outward in a slow arc that will eventually bring it back around. It is also moving in the direction of the constellation Hercules at a speed of about 20 kilometers per second relative to nearby stars. Everything is moving, always. And yet from here, from your bed, from the surface of this small, warm planet, it all feels perfectly still. That stillness is real too. Both things are true at once. You are hurtling through the galaxy at 220 kilometers per second, and you are at rest. Completely, genuinely at rest. Let your body confirm that second truth tonight. The first one will take care of itself. There is something strange about the way the Milky Way rotates. When astronomers first measured the speeds at which stars orbit the galactic center, they expected to find what physics predicted. Stars near the center moving faster, stars at the outer edges moving more slowly. Like the planets of our solar system, Mercury hurtles around the Sun in 88 days, while Neptune takes 165 years. But that's not what they found. Stars at the outer edges of the Milky Way move nearly as fast as stars much closer to the center. The rotation curve, as it's called, is almost flat when it should slope downward. This can only mean one thing. There is far more mass in the galaxy than we can see. Something invisible, something that does not emit, reflect, or absorb light, is winding through and around the Milky Way, exerting gravitational force. We call it dark matter. No one knows what it is. We know it's there because of its gravity. We know it surrounds the galaxy in a vast, diffuse halo, a cloud of invisible mass extending hundreds of thousands of light years beyond the visible disk of stars. We know it makes up roughly 85% of all the matter in the universe. But what it's made of, that we simply don't know yet. Dark matter may consist of undiscovered particles, unlike anything in the standard model of physics. There are candidates with names like WIMPs, weakly interacting massive particles, and axions, and primordial black holes. Experiments around the world are searching for it. Underground detectors buried deep in mountains, particle colliders, space telescopes scanning for faint signals. So far, it has not announced itself directly. It remains a presence known only by its effects. There is something quietly beautiful about that, about a universe that contains things larger than the visible galaxy, things we can feel but not see. It's a reminder that reality extends well beyond the edges of what we can observe. The darkness around the stars is not empty. It never was. Let that thought soften the edges of the night around you. The dark in your room is full of ordinary, harmless nothing. But the dark between galaxies is something else entirely. Something patient, something vast. You're safe inside it, held in it even. The Milky Way is not only stars. Between the stars, in the vast spaces between those glowing points, there is gas and dust. Thin, cold, drifting. So thin that in most of interstellar space, a cubic centimeter contains fewer than one atom. A laboratory vacuum on Earth is far denser. And yet, when you integrate that thinness across the enormous distances of the galaxy, it adds up to something significant. Roughly 10 to 15% of the Milky Way's visible mass is made of this interstellar medium, gas and dust between the stars. This material is not inert. It is the raw material of stars. When gas clouds become dense enough, when a shock wave from an exploding star passes through them, or when gravity slowly pulls them together, they collapse, they heat, they ignite. A new star is born. Some of these stellar nurseries are visible to us as nebulae, glowing clouds of gas lit from within by the infant stars they contain. The Orion Nebula, which you can see on a clear winter night as the faint smudge in Orion's sword, is forming new stars right now. As you lie here, as you breathe, stars are being born. The dust in interstellar space is not like household dust. It consists of tiny grains, silicates, carbon compounds, ice, each less than a micron across. This dust is responsible for one of the most haunting features of the Milky Way, as seen from dark locations, the dark lanes and rifts that cut through the bright band of stars. Those dark patches are not gaps in the stars. They are clouds of dust so thick they block the light behind them. The Great Rift, that dark corridor running down the center of the Milky Way, is a long, irregular cloud of interstellar dust stretching for thousands of light years. Ancient peoples who lived far from city lights knew these dark patches intimately. Some cultures in South America developed a tradition of dark constellation astronomy, reading stories not in the stars, but in the dark shapes between them. The Inca saw a llama, a fox, a toad, a serpent, all traced in darkness against a background of light. They were looking at gas and dust 100 light years away, and they saw a llama. That's a beautiful way to navigate the universe, by the shapes of what's hidden. Let your eyes close fully if they haven't already. Let the darkness behind your eyelids be its own kind of sky. The Milky Way is not alone. Surrounding our galaxy in a vast, loosely organized family are dozens of smaller galaxies, satellite galaxies, gravitationally bound to the Milky Way, orbiting it the way moons orbit planets. The two largest and most famous are the Magellanic Clouds, the Large Magellanic Cloud and the Small Magellanic Cloud. They are visible to the naked eye from the southern hemisphere, appearing as detached, misty patches of the Milky Way drifting near it in the sky. The Large Magellanic Cloud is about 160,000 light-years away. It contains tens of billions of stars, irregular in shape, warped and disturbed by its gravitational interaction with its larger neighbor. In 1987, a star in the Large Magellanic Cloud exploded. The light from that explosion reached Earth and was observed. The first naked-eye supernova visible in almost 400 years. Astronomers around the world turned their telescopes toward the southern sky. A star that had burned for millions of years announced its death in a burst of light visible across 160,000 light-years of space. We received the light. And 3 hours before the light arrived, we received something else. A faint pulse of neutrinos, nearly massless particles that had passed through the entire star and through the Earth as though nothing were there at all. Underground detectors caught them. A dying star sent us its ghost before we saw its light. There are also smaller satellite galaxies, faint, diffuse structures called dwarf galaxies, some of them so loosely bound that they're being slowly torn apart by the Milky Way's gravity as they pass close by. The Sagittarius dwarf galaxy, discovered only in 1994, is currently in the process of being consumed. Its stars being stretched into long streams and absorbed into the disk of the Milky Way. This is how galaxies grow, by absorbing smaller ones. The Milky Way has eaten many galaxies over its lifetime. The debris of ancient mergers still traces ghostly streams through the galactic halo. Even galaxies are not permanent. Everything flows. Everything becomes something else. Your body is doing its own version of this right now. Cells completing their work, systems settling, energy slowly quieting. You are also in the process of becoming something slightly different by morning. Let that be gentle. Let it be easy. There is a galaxy on a collision course with ours. The Andromeda Galaxy, our nearest large galactic neighbor, is currently approaching the Milky Way at approximately 110 kilometers per second. At that speed, the two galaxies are expected to collide in about 4.5 billion years. The word collision suggests violence. It suggests crashing and breaking. But the reality would be something far stranger and more graceful. Galaxies are mostly empty space. Even in the densest regions, the distance between stars is enormous. When two galaxies collide, the actual chance of any two individual stars colliding is vanishingly small. What happens instead is a gravitational dance. The two galaxies passing through each other, pulling and distorting each other's structure, spiraling together over billions of years into something new. Astronomers have simulated what this merger might look like. In the early stages, the spiral arms would be stretched and distorted. Stars would be flung into new orbits. The night sky, if there were anyone to look up, would gradually fill with the glow of the approaching galaxy, spreading wider and wider across the dark. The two galaxies would pass through each other once. Then gravity would pull them back. They'd pass through again. Slowly, over hundreds of millions of years, they would merge. The two spiral galaxies combining into a single, larger, elliptical galaxy. Astronomers have already given this future galaxy a name, Milky. Our Sun will almost certainly survive the merger. It will be in a different part of the new combined galaxy, in a new orbit around a new center. The night sky will look completely different from any planet that remains habitable. But a planet could remain. This is all 4.5 billion years away. In that time, entire mountain ranges on Earth will rise and erode. The oceans will change. Life, in some form, may persist. The universe does not rush. It lets things take the time they need. You have all the time you need tonight too. There is no hurry. Let your breathing match that pace. Slow, unmeasured, patient. Is there life elsewhere in the Milky Way? We don't know. It is one of the most profound open questions in science, and perhaps in human experience. What we do know is this: the conditions for life as we know it are not rare in the galaxy. Planets are common, incredibly common. The Kepler Space Telescope alone, during its survey of a small portion of the sky, found evidence for thousands of planets around other stars. Extrapolating from that data, astronomers now estimate that there may be more planets in the Milky Way than there are stars, potentially hundreds of billions of worlds. Some of those worlds orbit their stars at just the right distance, in what's called the habitable zone, where liquid water could exist on the surface. Rocky, Earth-sized planets in habitable zones are not rare, and water is not rare either. It has been found in interstellar space, in comets, in the atmospheres of distant planets, locked inside the moons of our own solar system. The building blocks of life, organic molecules, amino acids, carbon compounds, have been found in meteorites, in interstellar clouds, in regions of the galaxy far from any star. The chemistry of life seems to arise naturally wherever the conditions allow. Whether that chemistry has crossed into biology, into something that grows, adapts, remembers, somewhere else in the Milky Way, we genuinely do not know. The silence is not an answer. We have only been listening for a cosmic instant. Our radio signals have traveled less than 200 light-years from Earth, a tiny bubble in a galaxy 100,000 light-years wide. If there is someone out there, they might not have received our message yet, or we might not have received theirs. It is also possible that we are alone, that the emergence of life is so improbable that in a galaxy of hundreds of billions of stars, it happened here and nowhere else. That possibility is not comforting exactly. But it does make the fact that you exist, here, tonight, breathing quietly, feel something like a miracle. A soft miracle, unhurried, real. On a truly dark night, far from city lights, the Milky Way is visible to the naked eye. It appears as a soft, irregular band of light, like a torn piece of gauze stretched across the sky from horizon to horizon. In the darkest locations on Earth, it casts a faint shadow. The shadows are faint, but they are real. Most people living today have never seen it. According to a study published in 2016, roughly 1/3 of humanity cannot see the Milky Way from where they live because of light pollution. In Europe and North America, the figure is closer to 60%. In places like Singapore and Kuwait, nearly all of the natural night sky has been lost. The night sky that ancient astronomers mapped, the sky that inspired mythology and navigation and music, is gone from most of the world's cities. The stars are still there. We simply cannot see them through our own light. There is something quietly sad about that. A connection, several 100,000 years old, between humans and the night sky, interrupted in a single century. But it is also recoverable. Drive a few hours from a major city on a clear night. Go somewhere flat and open. Wait 20 minutes for your eyes to adjust to the dark, and you will see what every human before the 20th century saw every clear night of their lives. The first time many people see the Milky Way with their own eyes, they describe the same experience. A feeling of smallness that is somehow not frightening. A feeling of being part of something older and larger than they had fully imagined. A quietness that settles over them. Astronomers call the experience of the night sky cosmic perspective. Others have called it something less scientific. Awe, wonder, peace. Your eyes are designed to see the Milky Way. That sense of wonder you feel when you look at a photograph of a galaxy, that is a real and ancient response. It is your nervous system recognizing its home. Let that recognition settle into your chest now. You are home. You are held. The Milky Way did not appear all at once. It formed gradually over billions of years, a process that began roughly 13.6 billion years ago, only a few 100 million years after the Big Bang. The universe itself is about 13.8 billion years old. Our galaxy has existed for nearly all of it. In the beginning, there was no galaxy, only clouds of hydrogen and helium gas, slowly cooling and collecting under gravity. The first stars ignited in these clouds. They were nothing like our sun, enormous, unstable, burning through their fuel in just a few million years before exploding as supernovae and seeding the young universe with the first heavy elements. From those explosions, new clouds formed, denser, richer in variety. New generations of stars ignited, smaller, longer-lived, more stable. Some of them formed planets. The Milky Way assembled itself through mergers and accretion. Small proto-galaxies falling together, combining, building up mass. The ancient globular clusters that orbit the galaxy in a diffuse halo are thought to be relics of those early mergers, the preserved cores of dwarf galaxies swallowed long ago. The disk of the Milky Way, the flat spiral structure we see today, began forming about 8 to 10 billion years ago as gas settled into a rotating plane and star formation became more organized. Our Sun formed 4.6 billion years ago. It is a relative newcomer. When it ignited, the Milky Way had already been a galaxy for 9 billion years. There were already ancient stars quietly growing old as our Sun took its first breath. The Milky Way is, in a sense, a living thing, not in a biological sense, but in the sense that it grows, changes, consumes, and transforms. It is not static. Nothing in the universe is. And yet, on the scale of a human life, even of human civilization, it appears fixed, eternal. The same band of light our ancestors saw 50,000 years ago looks the same tonight. Continuity and change happening at different speeds, like breathing. The breath you're taking right now is different from the last one, and yet you barely notice the change. Let this one be slow and easy. What is the future of the Milky Way? In the shorter term, the next few billion years, it will continue as it is, slowly orbiting, slowly evolving, absorbing small satellite galaxies, forming new stars in regions where gas clouds are dense enough. Star formation in the Milky Way is not what it once was. In the galaxy's early history, new stars were being born at a much higher rate, perhaps 10 to 20 times higher than today. Now, the Milky Way forms roughly 1 to 3 new stars per year on average. The raw material, the cold gas clouds that collapse into stars, is slowly being used up. The galaxy is not dying, but it is maturing. Then, in about 4.5 billion years, comes the merger with Andromeda, Milky, the new combined galaxy taking shape over hundreds of millions of years. Further in the future, incomprehensibly further, the stars will one by one run out of fuel. The longest-lived red dwarfs will continue burning for trillions of years, far longer than the current age of the universe. But eventually, one by one, they will cool. The last stars will go out. What remains will be dark. White dwarf stars slowly fading, neutron stars, black holes. The galaxy will be invisible, but still present. Its matter still there, still gravitationally bound. And further still, on timescales of 10 to the power of 40 years, even matter itself may not be permanent. Some theories suggest that protons, the building blocks of atoms, may eventually decay. The last remnants of stellar matter would slowly dissolve into radiation. This is all extraordinarily far away. In the entire age of the universe, 13.8 billion years, we haven't even approached the beginning of these processes. You don't need to carry any of it. It is simply the future, doing what futures do, arriving slowly, changing things, becoming something no one has seen yet. Tonight, none of that matters. Tonight, the galaxy is exactly as it has been for millions of years. Quiet, vast, turning. And you are here in it. Somewhere in the Milky Way, right now, a star is dying. Not dramatically. Most stars end quietly. A red dwarf burning lower and lower over trillions of years. A sun-like star swelling into a red giant, shedding its outer layers in a slow, luminous cloud. A massive star collapsing in a fraction of a second into a neutron star so dense that a teaspoon of its material would weigh 1 billion tons. And somewhere in the Milky Way, right now, a star is being born. A cloud of gas in a spiral arm has grown dense enough. Gravity has begun to win. The cloud is collapsing, slowly at first, then faster. At its center, pressure and temperature are building. In a few 100,000 years, a blink on a galactic timescale, a new star will ignite. You exist between these events, between the last breath of one star and the first light of another. The Milky Way has been doing this, ending and beginning, dying and being born, for nearly 14 billion years, long before the Earth existed, long before life found its first foothold in the sea. There is something deeply comforting about a process that vast and that patient. It doesn't rush. It doesn't need to. It has all the time there is. You have been part of this process since before you were born. The atoms in your body have been through stellar cores, through supernovae, through the cold dark of interstellar space. They came together, improbably, into you. And tonight, they are resting. The galaxy can manage without your attention for a few hours. It has done so for 13.6 billion years. It will still be there in the morning, still turning slowly on its enormous axis, still lit by hundreds of billions of quiet fires. Let yourself rest inside it. Let your thoughts grow slower, less urgent. Let the images from this evening, the spiral arms, the dust clouds, the ancient stars, drift past you like objects seen through deep water. You don't need to hold on to any of it. It's already part of you. Tonight, we traveled across 100,000 light years without leaving where you are. We visited the galaxy's spiral arms and the dark lanes of dust between them. We sat close enough to Sagittarius A star to feel its gravity on the imagination. We watched the sun orbit slowly at 220 kilometers per second, arriving, eventually, back where it started. We listened for signals from other worlds and heard the beautiful, patient silence that may mean anything. We saw the Milky Way as it was seen by every human who ever lived under a clear sky. A river of light, a road, a reason to feel small in the best possible way. The galaxy will keep turning tonight. It turned through every night you have ever slept, and it will turn through every night to come. And you are a small, warm piece of it, made of its oldest elements, breathing its air, resting on a planet it made. Good night. Sleep well. And if you're still awake, that's okay too. There's more where this came from. Head over to the channel and pick something else. There are oceans to drift into, ancient civilizations to wander through, forests of mushrooms growing in slow silence. Something in there will carry you off eventually.